Welcome dear student. In this session we are going to start chapter number 6 in science, that is composition of a matter. So student, in this chapter we are going to see the composition of a matter. First of all student, what is a matter? So matter is everything around us which occupies space and has a volume. This is called as a matter. So let's start the chapter. Student, before starting chapter, let's answer some of the questions. So first is, what are the various states of matter? So various states of matter are solid, liquid and gas. These are the three states of a matter. Next it is, what is the difference in ice, water and steam? So students, the difference in ice, water and steam is in their stages, their state. So ice, water and steam are present in different state. That is, ice in solid, water liquid and steam is gaseous. What are the smallest particles of matter called? Students, this we have covered already in our previous chapter. So the smallest particles of matter are called atom. What are the types of matter? Students, there are three types of a matter, that are element, compound and mixture. So student, element is a substance that is made entirely from one type of atom only. Okay, and compound is two or more different elements which are chemically bonded together. Mixture, a group of two or more atoms that are chemically bonded together. Okay, that means in mixture is in which two or three like more atoms or elements are present. Now students, let's perform one activity. So in this activity we have to take some mustard seeds in a transparent plastic jar. Thread a long thread at the center of a big balloon by means of a needle and tie it very tightly. Stretch this rubber diaphragm and fix it on the mouth of the jar by means of a rubber band. Pull the diaphragm up and down with the help of the thread, first slowly, then with moderate force, and then vigorously, means very great speed. And we have to record our observation. So student, on page number 39 this table is given in which we have to record our observation. So here two columns are given. First column is of mode of pulling the diaphragm up and down, and second is of movement of the mustard cells, that how the movement vibration takes place in the mustard cell while applying the diaphragm, while pulling the diaphragm up and down. Okay, so in first when we will pull the diaphragm slowly, then the vibration happens in same places. When we will pull with moderate force, the vibration happens in different places. And while vigorous means very great speed, so vibration will happens all over the jar. So these were the observation of this activity. Students, on the above experiment we give energy less or more to the mustard seeds by pulling the diaphragm up and down, making them move differently. So the particles in the solid, liquid and gaseous states of matter have movement somewhat similar to that. An intermolecular force of attraction acts between the particles like atom or molecule of matter. The extent of the particle movement is determined by the extent of this force, and the particle of solid are very close to each other and vibrate at their fixed position. Student, here we have a diagram of interparticle distance. That means here we can see how the particles of solid, liquid and gaseous are arranged. Okay, now let's see. So solid get properties like definite shape and volume, and also high density and compressibility. Students, density means compactness of the particles or atom, and non-compressibility means the particles cannot be reduced in size by pressure. So solid have this type of property. and the strength of intermolecular force is moderate in the liquid state. You can see in diagram also. Though it is not strong enough to fix the particles in definite position, it is strong enough to hold them together. As a result, liquid have definite volume. However, they have fluidity and their shape is not definite but changes in accordance with the container. That means if we fill a jar with the water, the water we can hold the shape of that container. The intermolecular The intermolecular force is very weak in gaseous. Therefore, the constituent particles of gases move freely and occupy all the available space. Now, students, in this diagram, you can see the interparticle distance in the solid is very less. That means solid particles are very compact. They are arranged very close to each other, and liquid particles are very particles are little far away from each other. But in gaseous, you can observe that the particle of gas are very far away from each other. So students, in this diagram you can observe these particles of a solid. See, you can see how strongly the particles are joined to each other, and in liquid the particles are little away from each other. But in gaseous state, you can see how the particles are very far away from each other. So student, you have in your textbook one table is given which shows the characteristic of states of matter. So student, these are the physical states of matter, like solid, liquid and gaseous are there, and we have to see the characteristic of each, like solid, liquid and gaseous state. So for solid, it is rigid, plastic and elastic. Rigid means which cannot change its shape, and the volume of solid is definite, shape also definite, compressibility is negligible. That means in some cases of solid they can compress, but in some cases they cannot compress. And intermolecular force is very strong. Distance between particle is minimum. As you can see in the first picture of solid, distance is very minimum. And for the second state of matter is liquid, it's fluid. Okay, fluid means ability to flow. Okay, that means fluid will flow in any direction. The volume is definite, shapes is indefinite. That means it occupies the shape of any container in which it is poured. And compressibility is very small. Intermolecular force moderate, that means medium. Distance between particles is also moderate. For the gaseous state, it is fluid. Volume indefinite, shape indefinite, compressibility is very high. That means it can compress by it can reduce in size by applying a pressure. Intermolecular force is very weak. Why? Because the distance between the particle is very large. So students, you have seen that you have seen through this table the characteristic of different states of matter. Students, on this slide you have given one table in which the name of the material is given, and you have to write the chemical formula or composition and type of a matter. So for water, the chemical formula is H2O. Types of matter: compound, it is a compound. Carbon, chemical formula is C. Type of matter, it is an element. Oxygen, again oxygen, the chemical formula O2, and again it is a element. Air, so air is a mixture of gases, so the chemical formula for air or chemical composition for air is hydrogen, oxygen, nitrogen, carbon dioxide. So type of a matter, it is a mixture of different elements or different gases. So aluminium, brass, and similarly for aluminium, brass and carbon dioxide, you have to write the chemical formula and type of a matter by your own. This is the second method of classification of matter, in which we have seen the previous table. In this method, the criterion used for classification of matter is chemical composition of matter. We have seen in the previous standard that matter is classified into three types, that is element, compound and mixture, by considering whether the smallest particle of matter are similar or different and what are they made of. Student, the smallest particle of an element contain identical atoms. For example, oxygen molecule of oxygen contains two oxygen atoms in bonded state. You can see in the second, you can see in the right hand picture how the oxygen molecules combine together to form a O2. The smallest particles, molecules of compound, are formed by joining two or more types of atom to each. For example, each molecule of water contain two atoms contain two hydrogen atoms joined to one atom of oxygen. That means in water molecule, one oxygen atom is present and two hydrogen atoms are present, which are bonded together to form a water molecule. The smallest particles of a mixture are atoms or molecules of two or more elements or compounds. For example, N2, nitrogen, in which two atoms of nitrogen are present. Again, it is oxygen, in which two atoms of oxygen are there. Carbon dioxide, in which one atom of carbon and two atoms of oxygen chemically bonded together to form carbon dioxide. Again, water molecule, in which one atom of oxygen and two atoms of hydrogen are chemically bonded together. Similarly, the mixture and alloy brass contain atoms of copper and zinc, while bronze contain atoms of the elements copper and tin. Now students, here one table is given to us in which we have going to see the element compound mixture, which shows a schematic sub-microscopic picture and characteristic. So here we have given element, compound and mixture, three columns, and for the element example is given of nitrogen and oxygen molecules. For the compound we have nitrogen dioxide, nitric oxide molecules, and for the mixture we have nitrogen and nitrogen dioxide. Okay, so we are going to see this example one by one. Okay, so for the element it is nitrogen molecule. So constituent substance of element is only one, and it is that element itself. That means only one type of elements are present in this type of element. Okay, all the atoms or molecules of an element are alike. As you can see in the nitrogen molecule, the two atoms of nitrogen joined together, all the are alike, similar, that all are in white color. And for the oxygen molecule, all the atoms are present of oxygen, which are blue in color. So all the atoms in a molecule of element are alike and are joined each other by chemical bond. Like nitrogen will bonded by nitrogen to form N2 molecules. Oxygen with the bond together with oxygen to form oxygen molecule. Yes, atoms or molecules of different elements are different. That means nitrogen is different and oxygen is different. Now we are going to see the compound. So nitrogen dioxide molecules, that means NO2, in which you can see one atom of nitrogen that is of white color and two atoms of oxygen which are of blue in color. Okay, they are bonded together to form nitrogen dioxide. And in nitric oxide molecules you can see yes, white colored nitrogen is bonded together with one blue colored oxygen atom to form nitric oxide. So constituent substance of the compound is only one, and it is that compound itself. Okay, and all the molecules of a compound are alike, that means similar. The constituent atom of molecule of a compound are of two or more types and are joined to each other by means of a chemical bonds. It means these atoms are joined together to form a compound by means of a chemical bonds. The proportion of constituent elements in compound is constant. That means proportion of nitrogen and oxygen, it will be constant. The properties of a compound are different than those of the constituent or elements. Now why it is different? Because in this two types of atoms are present. Two types of atoms are joined together to form a compound. That's why properties of a compound are different. And mixture, for mixture we have N2 and NO2. So you can see white colored nitrogen bonded together, two atoms of white colored nitrogen joined together to form N2. And for NO2, one atom of white nitrogen and two atoms of oxygen, blue colored oxygen, joined together with the chemical bond to form NO2. And for mixture it is N2 and O2. So constituent substance of a mixture are two or more elements and are compounds. Atoms, molecule of a mixture are of two or more types. Okay, the constituent molecules of mixture are different from each other and are not joined by chemical bonds. The proportion of constituent substance in a mixture can change. The property of constituent substance are retained in the mixture. So student, this was about the state of a the schematic submicroscopic picture and characteristic of states. So different state of a different types of a matter. So student, I hope this session you all have understood this session. Next part we will continue in our next lecture. Thank you students.